Hello everyone. Today we will be working on the first lab of the quest, Intermediate Machine Learning, TensorFlow and GCP. As we can see here, Machine Learning with TensorFlow is the lab we'll be completing today. This quest takes you beyond the basics of using prewritten models and teaches you how to build, train, and deploy a model on Google Cloud Platform. We'll start by giving a brief introduction on TensorFlow. TensorFlow is a Python library for fast numerical computing created and released by Google. TensorFlow makes it easier for beginners and experts to create machine learning models for desktop, mobile, web, and cloud. Basically, TensorFlow creates models for devices. So we'll start off with the first quest of this lab. Here I'll give a brief description about the overview of what this says. So basically, here we start by creating an experimental framework in Python to replicate the basic linear regression model using TensorFlow. Then we will expand this framework to include more variables. In this lab, we will work with data processing and data modeling techniques that will allow us to develop a data model that will predict whether flights will arrive at their destination late based on specific details of departure, such as location, time of departure, actual departure delay, and taxi time, etc. These data are taken from the US Bureau of Transport Statistics website. So these are the main objectives. As you can see, develop TensorFlow framework in Python, extend the framework to include more additional features, as well as deploy the framework to the Google Cloud Platform. Now, before we start the lab, we have to speak about some requirements and setup. For example, everybody knows, the Qwiklabs, all of the labs are timed. It has a timer, basically 1 hour for this lab, and make sure you're completely free while doing this lab. As you can see, if the timer runs out, you will be denied access to the cloud platform and such. And make sure additional thing is we can finish the lab within 45 minutes if we try, and we also need extra 5 to 10 minutes at the end, since for deploying this project to the Google Cloud platform, it will take around 5 to 10 minutes. It'll take around 5 to 10 minutes for exact. So now let's start the lab. We will use the subscription model. As you can see, they have provided us with temporary credentials, basically just email address with password. We'll be using this. We'll forget about the GCP project ID for now, but we'll be using it later on. Now we'll click on the Open Console button, and they have used the same email address here. Just click on Next, copy the password from here, and paste it here. Accept the terms and condition. This is the Google Cloud Platform, also called the Cloud Console, and just agree on the terms and conditions for Google Cloud Platform. Now we'll be creating a virtual machine instance. Click on the navigation menu here and search for Compute Engine, and click on Virtual Machine Instances. So our virtual machine has been created. The green status is shown. This shows that it is running. I will click on the SSH link here. It will open up a black screen known as the SSH console or shell. This is where we'll be pasting all of the codes given here. Basically, I have done all of this, created the virtual machine instance, and I will get started. The first command is basically updating the package database, and one thing to always remember is soon as after copying and pasting on the console using the keyboard or control V, you have to click enter to run the command. After running, we'll close the console here, and again click on the SSH link here to open up the black screen, aka the cloud console. The next command here, the second command, basically is updating the package database uh, to the latest version. So we'll paste this as well. Click enter. We'll wait for it to run. It'll take a few minutes. Now we'll copy the third command, which is installing Jet. Jet is a version control system. We'll be using this to clone a repository for this lab. We'll see if it has finished. As you can see, the command has been run. Next thing is we'll again copy the command for installing Jet, and we'll paste this as well to install Jet. And then we'll go to the lab and copy this command will clone the repository. It's a command for cloning the repository in Jet. We'll paste this as well, press enter. Next, we will install the virtual environment. This command makes sure that the Python 3.5 can be used within this virtual environment. So we'll copy this as well, paste this, click on enter. Now we'll copy this as well and paste it here. You don't have to press enter for this. Now we'll press enter for the last command to be run, which is this. We have to click enter for this. Now we'll install the Python TensorFlow module, copy this as well and paste it here. Now suppose if you have come across any errors or something like in a red text color, make sure that you start copying everything from the start. Just start copying this and pasting this as well. If any of this command happens to have any errors, make sure you start copying from the beginning, and the errors will be skipped or will work fine, I guess. Now on this part of the section, we will create the training dataset that will be used to train our experimental models. As you can see, they have said that taken the source data files from the website of the Bureau of Transport Statistics website. And firstly, we'll be using some Linux commands. For example, mkdir means to make a directory or folders in some operating system. For example, in Windows we're creating a folder. In here will be in Linux, it will be called creating directory. We'll copy this and paste here as well. Now the next these two commands are basically creating a local environment variables. Copy this as well and paste it here, click enter and copy the project ID variable as well and paste it here. Here we are, and this command is basically creating the training dataset by extracting about 10,000 records from one of the source training data files. We'll copy this as well and paste it here. So everything has been run, and this command creates the test data. We'll paste this as well. Click enter for the last command, this command to be run. Now this section or step is to create the TensorFlow framework. Now basically they have said this the Python code to use TensorFlow to train and evaluate experimental data models. Firstly, we'll test this data locally, not use after everything the scripts have been run, then only we'll deploy to the cloud. So basically, For deploying, we'll have to make sure the Python codes are all in Python modules, not in scripts. That's what this means. That so first we'll create the folder structure. This basic means making a directory. That means creating a folder called TensorFlow. CD means changing directory to TensorFlow. Basically means moving to the folder TensorFlow. Same as mkdir, creating another file called flights inside TensorFlow. Moving on to the going to the file folder flights, as well as in creating another folder called trainer inside flights, and so on. Now we'll be at the last we'll be on the folder trainer. We'll copy this as well and paste it here. Click enter. Basically we are now on the trainer folder here inside TensorFlow. Touch is a command to create a file in Linux. Since we said we are using Python modules rather than scripts, and the file init.py must exist. I'll copy this as well and paste it here. Press enter. And the nano command is to open a text editor in Linux system, same like Notepad for Windows. It will create as well as open the file called model.py. We'll copy this as well and paste it here. Soon after pasting, you'll see that we'll open the text editor here. In the model.py file, basically this one, we shall import TensorFlow module as well as define global variables that will be used as the data schema for the source data files. So basically we'll copy this import statements and paste it here on the file. Now we'll paste we have pasted this command at the top of the file, and we'll copy this at the end of the file, basically down of these commands. Now basically this file is done, and in order to save this file we have to press Ctrl X first, Y, then enter. Basically it has been written here, press Ctrl X then Y and enter to save. To save any file in the text editor we'll have to follow these commands. Now that's done, we'll move on to creating another file called task.py. We'll paste this here. It'll open up another text editor with the file task.py. Now we'll copy this file as well onto the task.py file. We'll paste this here, and we'll copy this and paste it at the end of this file. Now we'll have to save this task.py file, Ctrl X, Y and enter. So basically the file has been saved. So basically now we'll run the script. Basically these all are scripts, right? So we'll run the scripts to make sure it has been working right, everything's in its place and everything. If it has worked correctly, we'll get a output as such. Everyone will get the same output as such. We'll check our progress. If it has gone green, means everything is all right. So in my case, assessment has been completed. Now we'll edit the model.py file before the same one we have created before. We'll open up it'll open up this. It has been already created we have created that. Now at the top of the file we'll have to insert these codes as well. It will be below this command, this import TensorFlow. So below this we'll copy paste this as well. Now we'll add the get features function definition at the end of the file, and we'll go scroll down and paste this as well. And we'll add the linear model function above the get features function, or we can add it at the end. It's all right, we'll add it at the middle. So basically, linear function as well as get features function has been created. In Python, in order to create a function, it will have a command called def. Def means define, just so you know. Now we'll copy this command and paste it below the define read dataset file. That means it will be pasted here at the top. As you can see, below this function, we'll paste it here. Make sure the indentation, that is the space, is same as this. It has been like this, so don't bother changing this. So basically now our read dataset function, that is this function, read dataset function, will look like this, same as this. Before that, we'll also have to copy paste this, the return statement, below at the end of the features label. Sorry, it will be here. So now our code will be same as this, as they have shown. In the node, they just say that make sure the indentation, that is, see, these functions are intended two spaces after. Make sure it is same indentation, otherwise Python will consider it as an error. And we'll copy this file as well and paste it here at the end of the file, as well as this function called run experiment. Now basically model.py file is done. We'll save this file with the commands Ctrl X, Y, then enter. Now the next step is to modify the task.py file. We'll copy this and paste it here as well. It will open up the task.py file. We have already created it before, and it will have some commands and functions. We'll copy this file and insert it below this comment. As you can see, in Python, comments are written with the command hashtag. We'll paste this here. It has to be like this, and we'll copy this below, and we'll copy this command and paste it below this file, this command in the file. We'll search for this command in the file. So basically it is here. We'll paste this below this. Now we'll copy this and replace everything, that is, we'll remove everything from here till the command called call read. We'll basically delete everything. Now we'll paste the commands here. Basically now our file is done. We'll save task.py file as well with the commands Ctrl X, Y, and enter. Now we'll run the task.py file using these commands to make sure the scripts are running correctly. We should get an output similar to this one. We'll mainly focus on the recall value, that is 9.9611. We'll search for this here. In my command, yes, I have got the same value, recall 9.9611. Everyone will get the same. Now, whatever code we have saved is called scripts. However, we are developing this code so that we can use Google Cloud Machine Learning to perform the experiments. Cloud ML requires that the code can be called as a Python module, not just as a script. The commands here provide the basic framework to allow the trainer code to be called as a module. We'll copy this and add it to the console here. Paste this as a press enter. Now we'll edit the setup.py file. It will create as well the setup.py file. We'll paste this here and press enter. As you can see, these are just the copyright licensing. You don't have to worry about that. It's not an error or something. We'll copy this command and paste it between the brackets mentioned here. Now that's done. We'll save this file with Ctrl X, Y and enter. Saving file uses these commands. Now we'll update the Python path environment variable to allow you to call your trainer model without specifying the path every time. We'll copy this and paste it here. Now we'll execute the trainer task, copy this, run the scripts. Now it is module, so we don't have to keep on saying scripts. So since we can here you can see there's an error in it's saying that no module name model. Everyone might get the same error. If you don't get the error, you can skip these two commands, but since I have the error, I'll copy this command and paste it here. Present it will open up this file, and basically they're asking us to make sure the import model has been commented. That is, hashtag means it is a comment, and this one this line has the comment has to be removed. We'll move on to this file and add a hashtag here. Make sure it's commented properly and remove the comment from here. Basically it is done. Make sure there's no space after anywhere in the code. Indentation has to be perfect. So we'll save this file. It is not mentioned here, like nowhere here it is mentioned to save the file, but we have to save the file using Ctrl X, Y and enter. Then what we'll do is again run the same above trainer task code, and we'll paste this here. As you can see here, we should get an output similar to this one. There'll be, before when we had run this, there was an error. Now there will be no errors here. As you can see, I got the same recall value 0.9611, same as here. Now I'll check my progress. Assessment completed has to be shown. Now we'll edit the model.py file to call the cloud ML. We'll paste this here. It will open up the file here before that we have created. Now we'll scroll down until we find the function linear model and insert the function we just copied here and paste it over there. Basically we'll copy this command and paste it above the function linear model. We'll find the linear model function here. We have found that. We'll paste the copied command over here. So that's done. We'll copy this as well and paste it below the return statement, return estimator. We'll search for the command return estimator. It has to be around, it has to be at the top. It has to be here somewhere. Yes, it's here. We'll paste this here, this command above the return statement. Now everything's done. We'll save the file with Ctrl X, Y and enter. Now we'll again copy paste the trainer task module and paste it here and press enter. We should get a output same as this. Only thing to note is the RMSE value has to be similar to this 0.302 or something. Since mine has the same value, I think the output is correct. Now the next part is to add new features as mentioned in the objective. In the objective, first part was to create the experimental framework. The second part was to add new features. Third part was to deploy it. The second, we have reached the second part. We'll copy this function and paste it here. Press enter. We'll open this file. Now we'll only thing to do is we'll search for the get features functions in the file and change it to the copied one. We'll search for the get features. Here we have found it. And basically what we're doing is making sure we are adding this statement over there, replacing the existing one. I'll delete everything from here and paste it here. Make sure there's no extra spaces here. Now we'll insert this get features row function above the replace function. That is, we'll paste the code here above the get features ch7, and the next command here, this function, these two functions, get features chapter 8 ch8 and get features function, will paste it below the this function, that is get get features ch7. So basically ch7 will come in the middle, ch8 will come below that. Basically now the file is done. We'll save the file, Ctrl X, Y and enter. Now we'll copy the trainer task module and run it on the console. We should get an output similar to this. Thing to note is the RMSE value, it has to be reduced to 0.26. It's getting more precise. As you can see, I have received the same RMSE value is 0.26. Basically they added a feature called time windowed averages. This additional time windowed data should improve the accuracy of the data model. Now we'll edit the model.py file as well. Paste this here and make sure basically we'll move on to the, we'll search for this function over there in the file, get features. Here they're asking us to comment out the last two statements and only keep the get features row function. So what I will do is I'll remove the comment from here and comment out the rest too. So basically that's done. I'll save this file with Ctrl X, Y and enter. Again execute the training task again. Press enter. You will get the RMSE value that output similar to this. RMSE will be again more precise, 0.24. We have received that. Now basically next step is to deploy the TensorFlow experimental framework to Google Cloud Machine Learning Engine. This is the third and the last part. We'll copy the environment variables and paste it here and press enter on the last command. Now we'll create a job name to allow you to identify the job and change to the working directory. We'll copy this as well and paste it here. Now and we'll copy the parameters code as well and paste it here. Now after running this, we'll wait for a few minutes, I suppose. And this job name has been used here, just so you know. After this has been done, the next step is to open the Google Cloud Platform, and what they're saying here is to click on the navigation menu and search for AI platform. I'll click on the navigation menu, search for AI platform, AI platform and sorry, AI platform, AI platform and jobs. AI platform and jobs. Mm, as you can see, the job here is being prepared. We'll have to wait around 5 to 10 minutes. Yeah, after 5 to 10 minutes we'll see a green tick over here. It shows that it has been prepared. Since we have around 30 minutes left, so it's fine, I guess, waiting for 5 to 10 minutes. I'll let you know after it has been prepared. As you can see, it has been deployed to the Google Cloud Platform. The green tick shows that it has been succeeded. Next task is to check the progress. It will see assessment has been completed. Now once the job has been done, we'll click on view logs. It will ask us to search for a description starting with saving dict for global step something. So we'll close this and enlarge this, scroll up and search for the statement there. Yes, as you can see, it will have a few analysis metrics shown. And basically, whatever we have done in the console here, this output here has been deployed to the Google Cloud Platform. You can see the output RMC value is 0.4, much more precise. So I'll check my progress again. After deploying to the Google Cloud Platform, it has shown assessment completed. So basically the lab is done, and hope everyone had hope everyone could understand some of the parts. I know some of the topics might be a bit frustrating and hard to understand. I tried my best. So basically it's done. After the assessment has been completed, you can end the lab, and you can see you have completed the first lap of this quest.